Going to be studying analysis of variance, and what we're going to be looking at now in chapter 8 we looked at hypothesis testing for one sample. Then in chapter 9 we looked at hypothesis testing for two samples. Now we're going to look at hypothesis testing for 3 or more samples, and we're going to be comparing means only this time. Remember, with the other two we compared proportions, means, and variance, or standard deviations. Now we're just going to be looking at the means. Analysis of variance only compares the mean. So the overview, there's two types. Well, analysis of variance is a method of testing the equality of 3 or more population means by analyzing their sample variances. There's two types: the one-way ANOVA, which is sample data is separated into groups according to just one factor. That's what we're going to concentrate on in this class. I'm going to just briefly touch on two-way ANOVA, which does the same thing, but we're looking at two factors. For example, maybe we're looking at weight and BMI for cholesterol, with the effect of a cholesterol drug. The two-way ANOVA is covered in much greater detail in the next class, the more advanced statistical analysis class. Requirements are: first, the populations need to be approximately normally distributed. They have to have approximately the same variances, and the samples need to be simple random samples from quantitative data, and the samples need to be chosen independent of each other. Do you remember we talked about independence and dependence in chapter 9? Remember, independent samples means you close your eyes, you select a sample for a sample 1. You close your eyes and you and completely randomly select another set for sample 2, and then you completely close your eyes and randomly select another set for sample 3, and so on. And these samples have to be categorized in only one way. So for example, suppose I'm looking at the weight of poplar trees. This is a problem in your book on page 545. We're going to enter this data into 4 separate columns. Column 1 are going to be weights of the poplar trees when no treatment is applied. Column 2 will be the weights of the poplar trees when just fertilizer is applied. Column 3 will be the weight of the poplar trees when just irrigation is applied. And column 4 will be the weight of the poplar trees when both fertilizer and irrigation are applied. Then you go to select stat, ANOVA. One-way unstacked means the data is in different columns. And then you enter column 1 to column 4 into the box labeled responses. Get out a test statistic called F. We've discussed the F statistic before. And it'll be 0.38 for this particular hypothesis, which means, and it shows my p-value to be 0.769. P is absolutely greater than any alpha that we would choose. And the most common, if no alpha is given in the problem, you assume an alpha of 0.05, which means we failed to reject the null hypothesis. There is not enough evidence at this 5% significance level to say that at least one of the means is different. Now I want to stop here for a second and make sure you understand how these hypotheses are stated. In ANOVA, the null hypothesis is mu1 equals mu2 equals mu3 equals mu4. That is the same as what we saw in chapter 9 when we said mu1 equaled mu2 as our null hypothesis. Now when we were just comparing two samples, like in chapter 9, we had the possibility of mu1 not equal to mu2, or mu1 less than mu2, or mu1 greater than mu2. But in ANOVA testing, it does not tell us anything other than at least one of the means is different from the others. They could all be different from each other. We could have 2 of them being the same. We could have 3 of them being the same, and the 4th one being different. The ANOVA test does not tell us that. All it tells us, if we do not reject the null hypothesis, if P had been less than the significance level, then all it tells us is there is enough evidence to say that at least one of the means is different. You would need to do post hoc testing later to determine which means are different from each other. We cover these post hoc tests in more detail in the more advanced statistics class. But in this, so if you reject the null hypothesis, you say there is enough evidence to say that at least one of the means is different. If you do not reject the null hypothesis, you say there's not enough evidence to say that at least one of the means is different. And the alternative hypothesis for ANOVA testing is always the words, at least one of the means is different. Just going to barely touch on two-way ANOVA. You're not going to be asked to do any problems in two-way ANOVA. But in this case, we're going to be looking at two different things. So the requirements are still that the populations need to be approximately normal. The populations still need to have the same variance or approximately the same variance. Still needs to be a simple random sample selection, which means no blocking. The samples still need to be independent of each other, but now the sample values are characterized in two different ways. And it's important that all the cells have the same number of values. That was not as important in the one-way ANOVA. You could have had one sample being a sample of 10 and another one being a sample of 12. They should be approximately equal, but in this case they need to be completely equal. So here's an example to show you what we might do. So here again we're continuing on with the poplar tree weights with two sites. I had 40 data values. You can find this in the Minitab lab book if you wanted to see this example. You're not going to be asked to do this on homework or on exams. So look at it or don't, or if you want to, but this will be covered in more detail in the more advanced class. But now we have a second factor. Besides the 4 treatments, we now are looking at 2 different sites. So my 2 factors are site 1 versus site 2, and then my second factor is the treatment, none, fertilizer, irrigation, and fertilizer and irrigation. You go to Stat, ANOVA, two-way, you enter the responses, all have to be in one column, and then you need to put all your row factors, so you need to put either 1 or 2 for the sites in column 2, and in column 3 you need to put your 4 different types of treatment for each of those values. Results for an interaction. So is there any interaction between site and treatment? Then you're going to get is there any effect from just the site? And then you'll get is there any difference between the treatments? So it really gives you 3 different tests. That's the end of chapter 12. Do not worry if you do not follow and cannot do a two-way ANOVA. Remember, that's covered in much greater detail in the more advanced statistics class, but I just wanted to point out to you that there is a second type of ANOVA. Now it's time for you to go do the assignments in 12.1. You need to watch the lecture for Lab 12, then download Lab 12 and complete it as you have done before. Please let me know if you have any questions about ANOVA or Minitab Lab 12. Thank you.